There's an edge. Have 20 minutes. Okay, I need to leave 10 minutes to solve this double slit test. So I only have 10 minutes. So I'm jumping a little bit faster. I hope I speak slow, still keep speaking slower, but flip it fast. This is the hydrogen molecule. Hydrogen molecule, two protons attract each other. Did you see this one? The so-called hydrogen molecule basically have a positive and negative charge, positive negative poles. So they are naturally attract each other. The two things. You know what is the strong force is? Strong force developed because they said that protons, positive charge, repel. They can never stay together. So we have to invent a particle called the gluon, glue them together. So let me look at this gluon. See, this is strong force, right? Strong force have a positive protons and neutrons, and then have a electrostatic repulsion. So how put them together? They use this rubber band, bend them together. Yeah. That's the force carrier called the gluon. Gluon is also another called a massless particle. Let me just introduce one thing. Who invented this massless particle? Smartest scientists, First, we know all the lights, right? Lights cannot emit a particle. We know that one. If you emit a particle, particles occupy the entire universe. They're impossible. So, based on the ingenuity of the science, they created this. Okay, we do have a particle come out, but they are massless. So that's why it came out called the massless particle photon, the carrier of light. It's a massless. Well, massless, but it has energy. So now we have called the massless energy. So now, see, mass and energy become two separate identities. In my definition, energy is nothing more just a motion of massed particle, just a motion of particle. That's based on all energy equation. Energy equals, kinetic energy equals mass times velocity squared, right? At 1/2 of velocity squared, that's Newton's law. So we know so-called energy is nothing more just a motion of a particle. Now, in modern physics, because of the concept of light is a particle, but a particle cannot have a mass loss because we know the laser point do not have that much mass fill out the entire universe. So creation of massless particle. The problem with massless particle, you have a massless particle, now you have a massless energy. So mass and energy separated. Then what happens? Two things are separated. One equation related them together is the most recognized equation in the whole universe. E equals mc squared. United, there's a pure energy with a pure mass. Mass without motion, massless. So that's why that equation has been created. Okay, now let's say what is a weak force? Weak force is another piece of a puzzle current theory cannot solve. Say, we have a strong force binding them together. We have electrical force, repel them together. Why we see atoms losing matter, called radioactivity? It's parts of material fly out. Radioactivity is basically a smaller particle fly out of a nucleus. So what happens? There's must have another governing force. Smaller, less than the strong force and less than the electromagnetic force somehow created this boson. This is what is called a boson. Yeah, Higgs boson. The boson is as a carrier of weak force. There is no weak force in my theory. The so-called the material losing is because of one thing. Because you remember the material has to structure with a certain structure. So all the positives have aligned with the negatives in order for this matter to form. It's a defect structure. Whenever you have a defect structure, before they form, somehow external environment impact is not perfect, just like a defect childbirth. And with defect structure, so you are positive and negative, not perfect aligned, positive, certain part of positive with positive. What happens? If you break the original, for some reason, in some environment, say vibration or some environment, and create enough force, started losing one matter, one piece of part, then every single part will gradually, because of the unsymmetric and also repel this defect structure, started losing matter. So why do I know this one for sure? So that's why defect material is so rare, like a radium. Radium's price is 1 billion times as higher as a gold price, because it's a radioactive material. It's a very rare to find. This is a defective material. By natural selection, it's very difficult to survive. So that's why it's very difficult to find, and that's why it's very so expensive. I think so far I answered all the 4 forces. 2 strong force and weak force are never exist, not even in Einstein's era. In Einstein's era said only 2 forces. Electromagnetic force being united, electromagnetic force, and gravity. So now gravity is just part of electromagnetic force. One thing about gravity, so why people say it's missing gravity? Why gravity is so difficult to find? Because they said every single other 3, 4 field forces always have attraction, also have a repulsion. Why gravity does not have a repulsion? So they can never comprehend it. Gravity is just definition of part of attraction. That's the missing process. Process will always turn out, attraction and repulsion end up with attraction. Okay, so here I wanted to make sure how universe was being created, how material was being created. In current model, proton and the proton positive charge will never match together, right? So they created is a fake force called a strong force. I'm for sure the one created strong force will win Nobel Prize. I'm for sure that the one. That's called gluon. Okay. So now in this model, you don't need to. You see, under pressure, under temperature, under pressure, if you the neutral, even neutral particle, even this magnetic particle, of course, they were aligned together. Neutral particle, if you close enough, pressure is enough, the positive and the negative aligned, they will be able to form clumping together. It's automatic, it's magnets, right? So under pressure, they can form the matter, they can form the other elements, and clump when elements are getting bigger and bigger, from planets to the stars to the galaxies, and when the galaxies collapse and associated too big enough, what happens? Exploded, big return matter to the fundamental form. This little magnet, called the universal magnetic particle, muons, just a fundamental form. And from a fundamental form, repeat the cycle. So this is called Big Bang. In my theory, Big Bang is just one cycle. Just one cycle in one corner. It's one drop in the ocean. Yeah, just 13.7 billion years old. Just one cycle. And then after another, this cycle, from the little particle form the planet and eventually back to fundamental form, just repeating the cycle. That's how universe works. And then mass. Now I want to solve mass, and then the only time left is for what is mass? We're talking about God's particle is a mass is given by somebody, by impact by somebody else, is fundamentally wrong. You know why it's wrong? It's wrong even by, they are not even the same species. Impactful, resistance force is based on size, based on shape. Gravity, mass is a body force. Body force is applied to every particle itself. Every single particle itself is a body force, uniform applied. It's not a surface related, right? So I'm 2 different species. So my explanation mass is what? Entire universe is a one unified magnetic field. So the individual mass basically is a magnetic particle, a composite particle, right? In this magnetic field, we'll have what is an attraction force from this unified field. So the so-called called inertial mass is resistant to the attraction. Is a resistant force to the attraction force through this universal magnetic field. This is a body force. Magnetic field force is a body force. We're talking about the surface resistance. That force is a surface contact force. In Newton's theory, it's environment impact have nothing to do with matter itself. Okay. Oh, okay. So dark matter and dark energy. Oh my goodness. What happens to? Yeah, can you make it? Okay, got it. Where did, oh, dark matter, okay. Oh, yeah, this one, yeah. Oh my goodness, I have to apologize. Today might run over.
Supermassive black holes may be the source of huge amounts of gravity, but they don't have enough power to hold galaxies together. In fact, according to the laws of physics, galaxies should fly apart. So why don't they? Because there's something out there even more powerful than a supermassive black hole. It can't be seen, and it's virtually impossible to detect. It's called dark matter, and it's everywhere. Astronomers have figured out that supermassive black holes live at the heart of galaxies and pull stars at incredible speeds. But they're not strong enough to hold all the stars in a gigantic galaxy together. So, what does hold them together? It was a mystery until a maverick scientist came up with the idea that something unknown was at work. Back in the 1930s, Swiss astronomer Fritz Zwicky wondered why galaxies stayed together in groups. By his calculations, they didn't generate enough gravity, so they should fly away from each other.
And so he said, well, I know that they haven't flown apart. I see them all gathered together in this nice collection. Therefore, something must be holding them in place. But our own gravity was just not strong enough. And so he concluded that it must be something which nobody had detected before, nobody had thought about, and he gave it this name, dark matter. And this was really a stroke of genius.
If what Zwicky called dark matter held galaxies together in groups, perhaps it also holds individual galaxies together. To find out, scientists built virtual galaxies in computers with virtual stars and virtual gravity.
We did a simulation where we put a lot of particles in orbit in a flat disk, which was just like the picture of our galaxy. And we expected to find that we get a perfectly good galaxy, and we were looking to see if it had a spiral or whatnot. But we found it always came apart.
There just wasn't enough gravity in the galaxy to hold it together. So, Oestreicher then added extra gravity from virtual dark matter.
It seemed like a natural thing to try, and it solved the problem. It fixed it.
Gravity from dark matter held the galaxy together.
Dark matter acts as a sort of protective scaffolding for galaxies that really holds them up and holds them in place and prevents them from falling apart.
But scientists still have no idea what dark matter actually is.
Dark matter is weird because we don't understand it at all. It's clearly not made of the same stuff that you and I are made of.
You can't push against it, you can't feel it, yet it's probably all around us. It's a ghost-like material that'll pass right through you as if you didn't exist at all.
We might not know much about dark matter, but the universe is full of it.
So the dark matter, weight for weight, makes up at least 6 times as much of the universe as does normal matter, the stuff that we're all made from. And without it, the universe just wouldn't work the way that it seems to work.
Just one comment about the dark matter. It confirmed we're missing matter, right? 6 times missing. And this one gentleman, Keiko, said it may surrounded all us, we just passing through, we just do not feel, because the size is so small. We know neutrino size is millions of times smaller than electrons, and the passing Earth have no resistance at all. And this fundamental particle, magnetic particle, is even smaller than neutrino. Of course, current measurement will never detect the pressure exist. So that's basically, that's the matter missing, means entire space. Whenever you see the lights, you know there are no vacuum here. They're all medium material covered, saturated the entire visual space. If really dark, that means that part there's no material. That's fine. Okay. What is dark energy?
Now, scientists have found another force at work in the universe. It's called dark energy. Dark energy has the opposite effect of dark matter. Instead of binding galaxies together, it pushes them apart.
The dark energy, which we've only discovered in the last decade, which is the dominant stuff in the universe, is far more mysterious. We don't have the slightest idea why it's there.
What it's made from, we don't really know. We know it's there, but we don't really know what it is or what it's doing.
Dark energy is really weird. It's as if space has little springs in it, which are causing things to repel each other and push them apart.
Far in the future, scientists think that dark energy will win the cosmic battle with dark matter. And that victory will start to drive galaxies apart.
Dark energy is going to kill galaxies off. It's going to do that by causing all the galaxies to recede further and further away from us until they're invisible, until they're moving away from us faster than the speed of light. So the rest of the universe will literally disappear before our very eyes. Not today, not tomorrow, but in perhaps 1 trillion years, the rest of the universe will have disappeared.
Okay, in my theory, dark energy is just the motion of this missing dark matter. Okay, number one. Number two, if you listen carefully, they said dark energy somehow said it's very weird. Seems like it has a repulsion, like an elastic, you have a repulsion force, like spring, they mentioned about it. That's tell you the density is. In order for wave, we know the transmitted light has to have wave. In order for wave to work, wave have a certain density. How dense? Has to be elastic. In order to be elastic, when you compress elastic, when you compress more, it can expand it back. You have to have this kind of problem, have attraction and repulsion to make matter to be elastic. So that's why we said why we're bouncing the ball. The ball can bouncing back. There is a repulsion there. That's the confirmation for me. Oh my goodness. Entire universe is made by magnetic particle. They have a repulsion force. That's the essence, necessary ingredient for the universe to work. Okay, that's another thing. Dark energy. Let me see evidence. Okay, I'm going to go through the evidence so fast. Say the evidence about no electrons. Based on my models, the nuclear size is the same as atom size, and the electrons is just a little magnetic particle attached to the nucleus, right? And so this is about evidence. If anyone feels electron in the, if you get an electric shock, you will know it. So this is basically no living being actually that feels they have any fiber has electrons moving. Another thing is that we have atomic images. We already be able to image the size as smaller as half nanometers. Basically atomic size. We know it, and we have a probe to touch it. There's no impact whatsoever with the electrons impact on you. So we have images. Another thing is from chemical reaction. I asked the very accomplished chemist in the center. All the chemical reaction based on covalent, two bond, ionic bonds and the covalence bond, have a certain structure. That means share the same electron. The electron at a certain location, you cannot fly away. If you fly away, chemical function will no longer working. So millions evidence. Almost every chemist will agree with me. Electrons is not flying. No, flying nowhere. They are attached there. We are sharing there. They are not goes away. So another thing, give you what is a nucleus looks like. It must have a physical evidence. What is atoms look like? So I do find that this is called ferromagnetic particles. If it's particles completely ferromagnetic in the field, it forms this type. See, this is a ball shape with a spike outside. Where comes the spike? This spike are individual, are not non-neutrino, is basically like an electron, have a charge, has a positive poles. Look at this one. One thing I found amazing is I mentioned about J.J. Thomson's prompt proving model. So he's a two generation student. Win Nobel Prize by prove he was wrong. Actually, he was right. So, I just want to pay my respect to him. You know. And another thing is about where is the energy level. We know we have a spectrum, different spectrum. How can you duplicate the energy level? So-called energy level, basically electrons. Electron has dimensions. Just one electron step on another. See, I stepped 3. And by doing that, I can duplicate the entire chemical elements. There's another view of the what is look of a relay nucleus. And now I try to demonstrate it. This very evidence being accepted by quantum mechanics, right? So this is a one electron jump from orbit to orbit to match 3 lines. Remember, hydrogen atoms have more than 3 lines, but they only pick the 3. You know why? Because mathematics only work for 3. Okay, let me look at how many lines here. 1, 2. Here's 2 lines. 3, 4, 5, 6 lines. Completely based on structure. I use the hydrogen structure. Completely match. The most important thing is this. Let me tell you. I'm sorry. I point to my computer. Nobody can see it. This is called the fine structure. The fine structure has been demonstrated again and again. It's always true. This fine structure, very close, one line, very close, 2 different configurations, which actually exactly match 2 different configurations in my model. In the hydrogen molecule atom comes 2 flavors. Exact match. At this point, I told myself, quantum mechanics at the beginning of the end. And so why so significant? So now I try to help if there's chemistry in the meeting. I try to solve chemistry problem. The most mysterious one is called the quantum principal quantum level. I think they represent the KLM and the quantum level. No explanation why each quantum level only have a certain different number of electrons, right? And also this is called the architecture rule. Architecture rule say, all the chemical property determined by outer layer of the number of electrons. Why you have 8 outer number of electrons, you got the most stable size, right? Let me demonstrate. This is oxygen molecules. If you look at it, it's a quantum level. The first energy level, you see vertical. If you look at it, the first the 2 electrons are opposite in the vertical axis, and the other 6 in plane, which means what? In the same sphere, we have 2 quantum levels. 2 quantum levels. So all current models say different quantum levels, different on the different distance. That's not exactly correct. I believe it's not exactly correct. And then this is a manifestation of how I believe this model captured correct. This is a water molecule. Water molecule and hydrogen molecule and oxygen molecule, the most studied structure in chemistry, in the history of chemistry. You look at a water molecule. How do we know water molecules structure? You freeze the ice. Ice freeze and manifested. If you look at the ice size, always 6 sides. I try to find all the snowflakes. And then you look at it, you look at the match of my of this model, 6 ions on the same plane, right? And the top and the bottom, are both are repel, So this is measured. So let's say, so number 1, the nature build in order for atom to be survived from nature, it has to have a symmetry plane. It has to have a symmetry because it has to self-duplicate. Without this one, the atom will be just in fundamental form, flying in this space. It's not going to be form solid matter. So in order for the matter to be exist, it has to reproduce itself. In order to reproduce itself, it has to have a rotational symmetry. It has to have a symmetry. Let's look at the current water model. If you look at the current water molecule, have no symmetry whatsoever. So I know by just instinct. I'm not criticize chemists wrong something, but I can say this was incorrect. Okay. Now, let's finish that this way.
I'm going to explain to you what's known as the central mystery of quantum mechanics. It was Richard Feynman, the American physicist, said, this is the central mystery of quantum mechanics. There's lots of weird stuff that goes on in the quantum world. Hit you with this, and it basically tells you what it's all about. It's called the two-slit experiment. I'll start with this. Imagine you have a source of light shining against a screen with two slits. Now, for the pedants in the audience, this source of light has to be monochromatic light of a particular wavelength, whereas of course a light bulb is white light, and that's made up of all the colors of the spectrum, lots of different wavelengths. But imagine this is just a single wavelength of light, and you can see the light is coming out in waves like ripples in a pond. That's the nature of wave-like behavior. As the light hits the screen, it squeezes through the two slits, and each slit in turn on the other side becomes almost like a new source of light, and the light spreads out, it diffracts. And as the waves of light overlap, they will interfere with each other. So where a crest hits a trough, they will cancel. Where a crest hits a crest, they will amplify, and so on. And so on the back screen, you end up with what's called an interference pattern, a series of light and dark fringes, where the waves have either cancelled out or worked together in phase. That's fine, that's not quantum mechanics, that's a property of light that goes back over 200 years that we've known about, since the early 19th century. Imagine doing the same experiment again, but doing it not with waves, but with particles. Do it with grains of sand. So this is the same experiment, but I've tipped it 90 degrees. Rather than waves that are spread out, that wash up against the two slits and squeeze through, here you've got individual particles of sand, and each particle will either go through one slit or the other. And so you see they will sort of drain through, and you get two bumps underneath each of the slits. So the two peaks is reminiscent of particle-like behavior, whereas the multiple pattern of interference is wave-like behavior. What if we do the same experiment with atoms? Well, so imagine we have an atom gun, something can fire atoms, a stream of atoms. You can't see them because they're very small. Let's block off one of the two slits. So these two slits are the dimensions and separation of the slits is chosen appropriately to show us how atoms do things. And so far so good, nothing strange here. You'll see a lot of atoms hitting the back screen. So this will now have to be some sort of photosensitive screen whereby when an atom hits it, it'll give off a little flash of light to say the atom has arrived here. So the atoms are arriving as these little pinpricks of light that we see. Of course, a lot of the atoms will be blocked by the first screen. They won't go through that slit. But those that do get through to the other side, you can see there's a bit of spreading of the atoms. But if we didn't know anything about atoms, we say, well, that's fine, we can understand that. A lot of the atoms are going clean through the slit. Some are sort of maybe bouncing off the edge of the slit, and so they're sort of being deflected a bit, which is why you get a bit of a spread. The first mystery of quantum mechanics comes when we open the second slit. Because now we see something that's very much like the interference pattern we got with light. Rather than having two bands of spots where the atoms have gone through the two slits, it's as though the atoms have gone through the slits behaving like waves. and you get interference of the waves and you get these bands. If we know nothing about atoms or quantum mechanics, you could try and rationalize it and say, well, you know, maybe atoms behave in a very strange way, and only a certain number of them are allowed to all sit together. And so, you know, me and my gang, we're all going to go on this slit. No, sorry, no room for you. You go to the next slit above. And by the way, there's this rule that no one can go in between the two bands, but a few naughty atoms do. So there's a bit of a scatter. You know, we don't. There could be some forces between atoms that make them coordinate their actions in a way to give this pattern. That's not mysterious. That's just, we just don't know how atoms do things. But we can be clever, and we can force the issue. What if we were to not send the atoms all through at once, but send them through one at a time? Leave enough of a gap for the atom to get through to hit the screen. Of course, as I say, some atoms will hit the first screen and not get through, but those that get through will hit the back screen. So let's run the experiment again slowly. And gradually you'll see, as the atoms go through, they'll look like they're just randomly arriving on the other side. You keep sending atoms through one at a time, and gradually that same pattern appears. So each atom by itself is somehow contributing its small part to the overall wave-like behavior that we see in the interference pattern. How does it do it? How does, we know the atom's a tiny localized particle, we can't see it, it's too small to even see under a microscope, we're firing it at the screen with the two slits. Some moment later you see a flash of light on the back screen. It's arrived in a localized point, it's not spread itself out. You don't get sort of like a wash of sort of a faint light across the whole screen. It's a little point. The atom is localized, it's arrived in a certain location. And yet, it somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern.